Welcome, dear students. This is lecture 4 of investment decisions, the time value of money. So, if we go back in time, we will see that assets have different values. For example, nowadays a bread may cost somewhere between 1 or 2 euros, but in 1948 a bread costed only 8 cents, and that is guilder cents, not euro cents even. But also the average wage was a lot lower than it is today. And so let's say that in 1948, my grandpa had a wage of 10 guilder a week. So that's about, that would now translate to about 5 euros a week. Some other fact, the brutto national product, the gross domestic product of Germany was in 1970 $1,868 billion. And in 2016 it was 3,356 billion. So my question is actually, did the size of the German economy double over that period, or something else happened? There's something more to it. It's called inflation. And money loses value over time for some reason. So take this information into account from the previous slide. Suppose you could choose between I will give you 100 euros right now, or I'll give you 100 euro in 1 year. Which one of the two do you prefer? Would you rather have it now, or you rather let me save it for you and give it to you in 1 year from now? Take a moment of your time to think about this. Put your video on pause, and then you can put the answer. I will tell that to you next slide. So let me give you an advice for the increase of your equity. If you have this choice to receive 100 euro right now or next year, you'll choose to receive 100 euro right now. And that is because, and now take a careful look, the present value of receiving 100 a year from now is actually worth less than 100 euro. Yeah, that means that if you choose to receive 100 euro right now, you receive 100 euro. But if you make the decision of receiving it next year, then that would actually mean that you would receive 99 euro right now on paper. And the reason why I'm going to explain you right now. There's 3 reasons. There is risk, there's inflation, and there's interest. So first of all, there's a risk that I'm not alive next year. Now, that risk can be expressed as a percentage. Second, the amount of goods you can buy with a euro or 100 euro actually decreases that power. That's called inflation. And so you can buy less bread with 100 euro next year than what you could do today. And finally, there's also interest, not unimportant. If you receive it right now, you can already put it on the bank and receive interest for it. If we add up these 3 reasons, for example, 1% for risk, 1.5% for inflation, and 7.5% for interest, then you add up 10%, which actually is called the total discount rate, in which you can calculate this decrease of value. So this loss of value, how does this really work? Let's have a small example. Situation A, I give you 100 euro right now. That's easy. I give you 100 euro and you'll be 100 euro richer. You could put it on the bank and you could have some interest. Suppose 10%, which is rather high these days. But that means that in 1 year from now, with the interest rate, you will have 110 euros. In situation B, you actually expect 100 euros in 1 year from now. How much money would that actually be today? Well, the present value of receiving you 100 euro next year is actually 100 divided by this interest rate is 90 euro and 91 cents. So why do we need to calculate the present value of all future costs and revenues? And revenues is another word for incomes. Maybe you can think about that for a sec and put your video on pause, give the answer, and then press play again. Well, as we've seen that all costs and revenues, they depreciate over time. So that means that a year from now, if I would make the same cost or would get the same income, that would be less worth today. That would be less. So that means that if we want to compare all the costs and revenues together on an equal way, then we have to actually do a trick where we try to do all the costs and revenues on the same day. And that is going to be the present value. So what happens if this project, all the costs of this project and all the incomes of this project all would happen on the same day? Then I am able to subtract the costs from all the revenues and see what my net profit is. So remember that we do that calculation by means of the discount rate. The discount rate is a rate in which we can transfer future incomes and expenses to today, or if we want, into the future. The discount rate consists of the risk, the inflation, and the interest. So there's always a risk that something is not or is happening differently. There's always an inflation happening. In some countries there's also deflation happening, then the inflation rate becomes negative. But the European Central Bank always strives for a positive inflation of around 2%. That has to do with stimulation of the economy. And the third one is interest. So if I give somebody else some money to store it for me, then that person is able to invest it in something and make money out of that. And that is being rewarded with an interest rate for the investor, in this case, me. So now actually we reached the point where I can explain to you a new capital budgeting tool. And we call it the net present value. So we're going to indeed transfer all the future costs and future revenues to today. Obviously, if a certain cost or incomes happens today already, then we don't need to bring it back to the now. But most of the cost and incomes will happen in the future. So we call that the net present value of a project. And of course, we have a very nice formula for that to calculate that, in which the present value, so the money that is being brought back to today, that's our outcome, equals the future value of a certain income or cost divided over 1 plus the discount rate, which is called here interest rate, but it's the discount rate, and then to the power of the amount of years you want to bring it back to the now. So that means that if a certain income happens in 2 years from now, and you want to bring it back to today, then it will actually have to go to the power 2. So now, for example, you can calculate the net present value of 200 euro that you receive after 2 years from now with a discount or interest rate of 20%. Okay, so how do we use the time value of money in a project? Well, suppose you have a company and you have some staff and you have to pay them salary, but you would like to know what the present value is of all those salaries in the future, let's say in 5 years from now. Yeah. So you want to actually equally compare all that money together on one day. So we're going to use the present because yeah, we are already in the present, so that's easy. So you will have to, if you look at the little graph that I put here, you have to actually remember that the salaries that I pay in 1 year from now, I have to bring them back 1 year. But the salaries that I'm going to pay my staff in 2 years from now, I have to bring them back 2 years, and so on. So that means that actually it's quite a hassle to do the calculations. You can say, okay, I would like to bring back, for example, a couple of costs and a couple of incomes that happen in 5 years from now. I want to all bring them back. There's a couple of costs and a couple of incomes in 4 years from now. And well, I have to individually bring them back to today. So you have to do this calculation for all single cost and single incomes each time with this formula. Later on, I will give you a quicker way to do this. But for now, let's stick to this formula because that's now the one that you know. And take into consideration that the net present value determines the current value of project amounts of money in the future. And by that, you use the discount rate. The discount rate is actually depends on the average cost of capital, the weighted average cost of capital. We call that the WACC. Yeah, that actually is that's a measure for how much it costs to acquire capital to invest. Yeah, so in some markets it's easy to acquire capital because there's a large supply, and sometimes there's a large demand. So then probably the interest rate will be higher and therefore the discount rate will be higher. So the WACC is how much cost do I pay for having capital. This boils down to the discount rate, and the discount rate is used to calculate the present value. So now you can actually calculate the net present value of these single cash flows yourself, using the discount rate in the tables and the amount of years that you have to bring it forward. You can put the answer also in the table. Finally, you can calculate the net present value of your projected salary in 2022 with a discount rate of 3%. So suppose you earn 2,000 euros by then, how much would that actually be right now, 2 years earlier? Of course, we can also do this the other way around. Suppose I want to equally compare all the incomes and expenses, but not now, but in 1 or 2 years from now. Then we could calculate the net future value. And it will not surprise you that if the discount rate is 10%, that the future value of 100 euro received right now is equal to 110 euro received next year. Yeah. And that is that looks a bit strange, but that is because that 100 euro that I receive right now, I can put it on the bank and I get some interest rate, etc., etc. And then I will actually receive 110 euro next year. This can be calculated with the formula net future value equals the capital times 1 plus the discount rate to the power of the time you want to bring it forward. So that's in years. Yeah, check for yourself if this makes sense. Otherwise, also on this, we have a video that you can click on. So to make it even more clear in your mind. Let's have an example on net future value. Suppose you want to buy a car and that car costs 4,000 euros and they offer you to pay this in installments, right? So actually every year, so in the current present you don't have to pay anything, but in 1 year from now you pay 1,000 euros, etc., etc. So in those 4 years you have actually paid off the car. So the question is, how much did you actually pay if you take into account the net future value? Is that still that 4,000 euros, or is it more? Well, you can calculate how much you really paid for, or in other words, how much could you have had if you just saved it on the bank. That is being calculated with the same formula. So you have to bring 1,000 euros 3 years forward. That is with a discount rate of 5%, 11,557 euros and 63 cents. And the amount that you're going to pay in 2 years from now, you have to, the amount that you're going to pay next year, you have to bring that 2 years into the future. So that goes to the power 2. That becomes 11,002 euros and 50 cents. And then there is also an amount that you have to only bring forward only one time, which is 1,000 euros to the power times 1.05 to the power 1, and that is 1,050 euros. And then, of course, the 1,000 euros that is actually being spent in the final year, yeah, that is already happening in 4 years from now, so you don't have to bring that forward or backward. So that remains 1,000 times, just 1,000. So if you would add that all up together, then you will see that you actually have paid a little bit more than if you would have paid the 4,000 euros in the beginning right away. Yeah, and if you struggle with this, then keep in mind that if I would not have bought the car, I could have put it on the bank against interest rate, and then I would have saved this amount of money. So the time value of money is also important when you're depreciating your assets, like we discussed in the previous lecture. A certain asset loses value over time, and that is has nothing to do with the discount rate, but that's simply a matter of fact because it wears off and the market continues producing new products. And we have learned that the economic lifespan has ended when the operating costs actually outperform the performance value, and that the technical lifespan has ended when actually the asset cannot be used for any purpose anymore. So, but in the end, it can be that you have a certain residual value, as we have discussed. That is the value at the end of its economic lifespan that I can still sell it for. Yeah, that's still the how much it is worth on the market. So that's actually the amount for which I have put it on my balance sheet in that year, in the year that I'm going to say goodbye to this asset. You could, of course, already take into account this residual value today, that it's going to depreciate and have a certain value after so many years, by calculating the net present value of that residual value. Or you can bring it into the future by calculating its net future value. And remember that if I depreciate with a certain rate, that the residual value is never going to be zero, as you can see in this example. It can be close to zero, but it will never reach zero. So this residual value always has to be taken into account, and we will see why in a minute. Depreciation can be calculated in different ways. So suppose I have a printing machine, I could depreciate it in a straight line, which is the blue one. I just depreciate each year 10,000 euros, for instance. So that means that in 5 years, actually, it will be zero. So I can actually dump it because it doesn't have any value anymore. But as we have already seen, some assets have a different way of being depreciated, like cars. cars. Yeah, they always depreciate in with a logarithmic scale, which looks a little bit like the red line, more or less. But the red line goes up again, which is not being explained in this course why that happens. But you can also depreciate by machine hours. So the more the machine operates, the more it gets depreciated. That makes also sense because it wears off quicker when it is used more. In this course, we will mainly follow those three ways of depreciation, and I always will mention which of the type, which one we are actually dealing with. The other ones we actually don't use in this course. That brings us to the final capital budgeting tool of today. This is one of the most complicated ones that we're going to learn. The average rate of return, also called the accounting rate of return. This is actually a rate, an average rate, in which money is coming back to you for this project. Yeah, average per year. In order to do this, we use a formula that is split up into two parts. The average annual revenue, the number 1, is divided over the average invested capital, the number 2. Now, for the average annual revenue, you will have to take the revenue, so that is the income for each year. And if that's the same, you can simply multiply that with the duration. If every year the revenue stays the same. Usually that is not the case, so then you have to sum up all the revenues together, if you happen to know them. And then you, of course, we're talking here about the net revenue, so you have to extract the OPEX from that. So times the duration, then minus the CAPEX, because you have actually invested that, and then we divide it over the duration again to get the average annual revenue. Now that needs to be divided over the average invested capital, which is the average of two investments, the CAPEX and the residual value, because accounting people, they call the residual value an investment as well. It has an just like the CAPEX, it has a place on the balance sheet, and therefore it has to be it has a value that can be that can be invested in later on, and we have to take it into account. So the CAPEX plus the residual value have to be divided by 2 because there's 2 investments, and then you get the number 2, average invested capital. So if you divide that over each other, you get the average rate of return. So suppose that it's 0.01, then that is actually expressed as a percentage. So that means 1%. This was lecture number 4. If you have questions, and hopefully you do, bring them to the lecture.